Go to the cloud, off we go. All right, this is where we ended up on Thursday of last week, talking about call and return. And remember, the call and return architecture, really the goal here is I've got a bunch of like independent beds on the backside, these backend data sources, and they could be like really different stuff. Like I could have a relational database, non-relational, just an open file system, like who knows where that data is coming from. But from the application side, I don't want the app to see that complexity. What I want the app to see is just a single call essentially into this middleware layer. And then the middleware layer handles all that complexity of figuring out, oh, you need these 5 pieces. Here are those 3 databases that comes from. It'll do the appropriate calls, collect all that information as it comes back, because it's not going to come back at the same time, and then create a single response that goes back to the application. So that right in this dotted line here was this fan out. That dotted line really is the abstraction layer. Above that, the application just sees an abstract data call. On the bottom side of it, that's where the concrete stuff appears, and that's where we actually have to like figure out what the call is going to look like. But the app, like I could swap out databases, right? I could take a relational database out and replace it with non-relational. The application wouldn't change. It's exactly like the decoupled architecture we looked at, and you had just had a quiz question on. That decoupled architecture is this also in the architecture that we looked at for the web application, that dog fooding lecture. So we had a front end and a back end, and the abstraction was JSON in the middle. That was the data abstraction for us. Same thing here. Like it's still like you can think about it as front end, back end, right? The front end's the app server and the web server, back end's the database stuff, and the abstraction layer is here in the middle. It just allows the application to work generically, and it hides all this stuff back here. So I can, I could swap stuff out if I wanted to. And the bottlenecks here, I mean, the bottleneck is always going to be that single point of failure. So it's the middleware piece at this point is a bottleneck. And I've only got, well, this diagram only has one connection going into the middleware, but that box, that middleware box, that's what we're going to have to scale. I would assume that the data systems, these beds back here, they probably scale pretty well. Databases, generally speaking, scale quite well. And I'm going to have to make sure that the middleware is robust enough to handle the load. And the good news is that middleware like that, if I needed to scale this out, I'd probably scale it horizontally. So I just add more middleware servers, and then maybe I'd have to have a layer on top of that to direct traffic to those things, or just do it round robin or something. But I mean, this architecture scales pretty well to begin with. So I wouldn't be so concerned about bottlenecks in this kind of application. And the opportunity for abstraction is that dotted line. All right, let's go into more generic stuff. Like this is more webby sorts of things. And honestly, there's a lot of distinction here between 1, 2, 3, multiple tier architectures. Frankly, they're all the same. It just really depends on how many boxes you've got and what the connections look like between them. So in general, we're talking client server stuff. That's the classic web app. The client is the browser, the server is the web server on the back end. And of course, that's an abstraction too. There's probably a bunch of stuff going on behind the web server. But from the client's viewpoint, it's just a call into a web server. You also see this as a request response kind of architecture. So we might say request response. The request being the web request from the client, and then a response back from the server. And they, it's a silly picture from the book, but you just got a bunch of servers and the clients connect to it. It's not such a big mystery. We talked about thin client and thick client already, so I'm not going to go into that. But that's the question we're sort of asking ourselves as we look at N-tier architectures, this webby sorts of thing, like, is it thick, is it thin? Where does it make sense to do the work? As I mentioned, when we spoke about that in data architectures earlier up, or I guess it was data in general on last week's discussion, like a lot of times it makes sense now to have thick clients, thick meaning that the work is done on the client side, on the browser side, just because desktops are so capable now. I mean, these machines that we have are just astoundingly fast. And like, maybe I don't need to load the back end down, just have it return data, and then I can crunch that data on the front end. And the thin client, I guess, if I had some really, really heavy number crunching to do, or I could leverage that crunching on the backside. Like if I made a request and it took a lot of CPU cycles to satisfy that request, but I'm going to have the same request come in from a different client later on, I can cache them on the back end and improve performance that way. Maybe it's too much work for the front end to crunch. All right, so these are just web architectures. They go from, this sort of thing. This is the classic small website development sort of architecture where everything's on one server. I got the web server, business logic is going to be an application server, or just the code inside, maybe we're writing in PHP or JavaScript or something. So you're going to be business rules there. And then a database also, it's just all in one machine. This is how we develop typically, well, for small development tasks. If I have a larger task or a larger project, I'll probably stand up a second web server to do this. But this works fine, right? It's not all that performant because I've got this bottleneck here on the server side. If I'm doing a lot of database work, it might slow that box down. Usually the web servers are really efficient, so I don't have to worry about scaling the web server itself. And if I needed to, web servers scale really, really well with CPU and memory. So I could just throw some more CPU, some more memory in there if I needed to scale out the web server side. It's mainly the database side that becomes an issue pretty quickly. So that's the bottleneck itself is the server, right? Here's the 3-tier where we recognized, oh yeah, the database is slowing stuff down, so let's pull it out onto its own box. So now the app server has the web server and the application logic, the business rules and so on. The client is still the client, but now all it really have done is pulled out this database over here. But now like that's actually a really nice architecture. And in fact, I would guess that a lot of you guys would set up your projects that way, where the application server side is each team member's individual laptop or desktop. And then the data server would be living in the cloud on an AWS instance or Azure or wherever, just so that you had a single point of data. You all could work on the application and build stuff there, but you all would have the same view of the data instead of having to share the database around, which can be awkward sometimes. So that data server, even though it's shown here connected directly to the app server, that could live anywhere. Could live in the cloud, could live on a second data center, wherever. But now I've introduced another bottleneck, right? This connection right here, that's going to be an issue at some point, because as the app scales, as this stuff scales, back here, I'm going to have to scale the database at some point, and I've really got to manage the connections here from the app into the database. I can't just have a gazillion connections coming through, just wouldn't work. And in fact, when I'm thinking about delay, when I'm thinking about performance, like if I'm tuning a system, the very first thing I'm going to do is tune it with a shape like this. Let's put, let me just throw some boxes down really quick. So like if this is, let's see, I think I only need 3. If I had a system that looked like this, shape, arrows, paste. This is so much faster than drawing, right? And then a client. Let me get a client up here. All right, so that's my web. This is the client over here. And then I'm going to have, like here, this is going to be the web server. This one's going to be an application server. And then the database on the back side. It's the same diagram, right? That we just looked at. Okay, so if I have something like that, the client's going to make a call into that, of course. Shape, blah, blah. That. And like that. That's a beautiful picture, man. So if I'm thinking about tuning this sort of thing, because I want to make sure that I'm not overloading individual components, I can set the connection count. That's a really simple metric. I can take the number of connections that I'm allowing on each of these layers and then shape that so that I never overload anything on the back end. Because really what I'm worried about is the database. That's going to be the, generally speaking, that's the choke point. And so I can shape it like this. Shape. Bip. And this would be like number of connections. And like this. That. Text. Yeah, this is so much better than drawing on a board. Or number of connections. And the reason I would do this is what I'm saying here is that I'm limiting the number of connections on the web server. So let's say I've got 10 over there. Yes, I mean, this is 10 connections. It just means that here, I'm going to put like 12 connections. And then the next one over, this one, I would stick maybe 14 connections. It means that if I'm overloading anything, it's going to be overloaded right here, right? So that web server only allows 10 connections at a time. If I know that I only have 10 connections at a time, and I've allowed the app server to have 12 connections, there's never going to be a situation where I've got more connections coming into the app server than it has available, because I'm limiting this to 10. I've got 12 available. I'm never going to use all 12. And the same over here on the data side, I'm going to limit it there too. So I'm just shaping that connection curve, or well, that's a curve or not, but I'm shaping the number of connections just so that I've got some headspace. So the term you'll see is headspace. And headspace just means that back on this side, I've got extra capacity. If I reverse this curve, so I have a whole bunch of connections on the left side of this diagram, funneling down to the right, that's a bottleneck waiting to happen, because I have tons of connections at the web server side and fewer connections as I go into this architecture. I'm just asking for trouble. If I do it in this shape, now I've got excess, I've got headspace, right? Some headroom. I don't have to worry so much about overloading any individual component. We can tune all of those numbers, like the web server itself. I can specify the number of connections or the number of processes I'm going to use. The app server the same. And I'd probably use a connection pool of some sort to pool threads that are connecting out to the data side. And I can adjust the size of that too, the number of connections. They just keep going. Here's a replicated data system where I've got two databases back on the backside being replicated. There's a couple of ways to do it. I can do two things. I can mirror or shard. If I'm mirroring these databases, they're duplicates of each other. So data server 1 and data server 2 always have the same data, except when I write something to data server 1, there's going to be a lag, some latency before data server 2 sees that. And I can handle that in a couple of different ways. That's always going to be an issue when I've got multiple databases that have the same data. I can, in this little bubble here in the middle, I can have that sort of be almost like a write back or write through cache, so that changes actually happen here, and then they get written back simultaneously to these guys. Would I trust that? Yeah, I think I would, except in like a really, really super time critical situation. It's probably going to be more or less simultaneous if I'm doing writes that way. I also can have another process that would just stick another box in here. Let's stick a box back here and make it a smaller box. And that guy would have connections to the databases themselves. Like this. Let's move him over. That's sweet, huh? Da-da-da. Oh, come on, really? You gonna? Oh, that's weird. See, it's like that and that, and like that to there. That's a lovely picture. But that thing would be, it would be a data manager. So it would handle replication. And the replication would so they're basically, if I wrote something into data server 1, this replication box would know about it and immediately write that data to data server 2. That's a mirrored sort of system. The second way of doing it is sharding. And in sharding, I'm just going to break the data up. Maybe like we have 2 database servers here. So I put half of the data on one side and the other half of the data on the other side, on the other server, and both of them run simultaneously. In that case, this box right here in the middle, when a data request comes in, it has to figure out which of the 2 databases that data lives on and then hit the appropriate database. That's actually a really, really common way to horizontally scale a database system. Just break the data up. And I've seen, well, for example, global companies, they'll have a data center in Europe and a data center in North America, maybe on each coast, so West Coast, East Coast in North America. And depending on where you are, like physically located, you'll hit one of those 3, and they hold different data. So the West Coast one holds West Coast sales data, maybe Europe has European sales data, and so on. So it's pretty easy to figure out which way you want to go. And of course, there's going to be situations where you need data from both, but you just handle that in the application. So sharding works pretty well. Most databases like MySQL will just shard right out of the box. You just tell it you want it to shard, what the criteria are, and off it goes. Like it's not a big deal to set up. Actually, mirroring also, all the databases handle mirroring really, really well. And they typically use a master slave configuration. So the master database is slaved to a secondary database that they handle communication back and forth and keep the data consistent between the 2. And it just keeps going on from there. It's like every server is its own snowflake. HR, clearly you want HR completely isolated from anyone else, so they get their own server. Engineering, you don't let engineering touch anybody else's servers because they'll just screw stuff up. It's the same architecture really as all the other ones. It's just that we put different labels on the boxes. That's a consulting skill. Know when to put different labels on the boxes. So those are sort of tiered architectures. This stuff, this is really just, that's how web applications are built these days. In big applications look more like this, especially data-centric applications. And then we get to some more interesting stuff. MVC, let's talk MVC. I don't know why that's there. I'll do controller pub sub. Oh wait, pub sub is on the next slide. Hang on, let me just move that. Models, holy crow, that's a ton of stuff in there. We don't need all of that. I was going to move this pub sub down. To there. It really should go down here, I think. Sweet. Let's talk briefly about MVC. Can I just, there we go. So MVC, model view controller, that essentially is the web architecture that we looked at, but in a more formal sense. The idea of MVC is that I've got 3 components. I've got a model, and the model is the data. So the model is the data. I've got a controller. In a web application, the controller is going to be the buttons, the clicks, the links on the page itself, the things that the user can do with the application. Those are the controllers. And then the view, in a really clean MVC architecture, the view is only a representation of the data in the model. So the pure form of this is I have one source of truth, the model, which is data, the database on the back side. The model encapsulates state. And we say that state is, just because I think this is on the test I'm going to give you, state is, I shouldn't tell you, huh? It's really the values of variables. Spencer says, is the controller also the JavaScript logic on the page? Yeah, is that, well, it could be. So because I'm running code on the front end, so the JavaScript side on the front end of a web app, I could be manipulating data to perform a view function. I also could be implementing controllers. So it could be a little bit of both, Spencer. It just depends on what it's doing. So when I talk about state here, state changes, state queries, and so on, state is, what are the variables in the model? What's the data at a given moment? It's somewhere in this slide set is defined as the simultaneous value or the instantaneous value of variables, blah blah blah. It just means what are the values at a given moment in time. And in a perfect world, I'd only have one model, one source of truth, and I would query it. Anytime there's a state change, essentially, the state change means that the controller asks the model to make a change. Hey, I want to update this data or add some data to the model. That's the state change. The model does the update internally. So it changes the value of its internal variables, or it stores something in the database or modifies something in the database. That's the state change. And then you'll notice that there's a change notification event sent to the view. It's just telling the view that the data have changed on the backside in the model. It's up to the view really to decide whether it wants to update its own internal model or not. Because I've got the data in two places, kind of, right? I've got this model back here, and in a web application, I've got to send that data to the web app on the front side. So now I got the data in two places. So it's up to the view in that case to say, oh, I noticed that there was a change. Let me go get the new value. That's the state query here. So the state change is initiated by the controller asking the model to change its values. And then the model lets the view know, hey, I changed state. And depending on how you write the app, you might just send the data along or just a notice that it has changed. And then a second request comes in to actually update the data on the view side. So I mean, that's about as simple as you can get. Those are the three things that we do generically in applications. We manage data, we have some way to manipulate it, and we have some way to display it. So MVC is kind of the de facto architecture for most web architectures and other architectures too. Like we use MVC all over the place because it's generic and it works. Bottlenecks here, actually, not a lot of bottlenecks to talk about here. The real issue, I think, for MVC is, especially in the web, is that I have multiple copies of data. And let's think of, this view is sitting out on a client somewhere. The view and controller typically are on the client side. If I've got 1,000 people hitting my application, I've got 1,000 views out there essentially. And anytime data changes on the back end in the model, I'm going to notify them. There's going to quickly become a point where I've got just lots and lots of different copies of the model data. So I really have two models at that point. I've got one in the view side, I've got one on the model side. Like, which one is right? Yeah, the saying goes, a man with two watches doesn't know what time it is. Like, which is it? I don't know. So that's an issue we have to deal with. Anytime we're using data that is time sensitive, maybe it's a stop quote or something, the view's got to decide, do I need the updated data? Do I not need the updated data? Maybe I just saw a change notification come in. Do I immediately go grab the new stuff, or do I wait a period of time? Do I have stuff in cache that I need to invalidate? There's a lot of questions we answer when we start with this sort of shape. But as I said, this is kind of the shape of current technology. It's just kind of what we do. There's a whole bunch of slides in here about the model and what's in it and so on. Examples, I think those examples are in Java. That looks like, I don't even know what that is. Set size, it could be JavaScript, I guess. Anyways, a whole bunch of slides in here. honestly, what you need to know, I think, is just what I talked about on this slide. The rest of the slides are just kind of filling in a couple of details. All right, let me get back to something more interesting. Yeah, there's the same diagram, right? Just showing the browser as the client. And in that case, so all of that is the client side. And then this is the back end. No questions, I stunned everybody. Not a lot more to talk about. Also tell jokes for 20 minutes or something. Let's talk about pub sub. Zach, it's just a lot of detail that if you're interested, there's a couple of tidbits in there, but honestly, these architectures that we're talking about, they're really, really simple. I mean, they have to be simple, right? Otherwise they would just break all the time. You can't talk for an hour on something that's really, really incredibly simple. You just start repeating yourself. That's kind of the beauty of these architectures is they're all just really, really, we've taken them down to bare bones. You can't get much simpler than any of these, really. It's all important. Every word is a pearl. Let's talk pub sub. Yeah, I don't get that either. Who has that sort of time, right? All right, pub sub. So pub sub is straight out of the Gang of Four. If you've taken the data structures course, which I think we still teach, what do we teach it in Java these days? It's probably in Java. This is the original Gang of Four book. This is Vasilides and who the devil were they? I never can remember these people's names. Let's look at Amazon. The classic book. This one. Gamma, Helm, Johnson, and Vlisides. I'm sure you all have a copy of that, or will at some point in your career. I've got a copy. Well, I have a copy because I used to teach design patterns. That's the book we used. But this is right out of Gang of Four. It's the observer pattern. It's similar to a couple of other patterns. There's some patterns in that book that are pretty close to each other. Basically, it's this. This is the shape. So I've got a subscriber, and we're sort of out of the web specifically, although you can use this in web architectures as well. What is that? When you all say? One of those, oh yeah, I've read it, but no one actually has. Well, back in the day before the internet, like there was a whole set of books that everyone had, and you pretty much had them just to have them. You have them up on the shelf. And the Gang of Four book was a book that told other people, oh, he's a thinker. he's into the architecture of all of this, like he's an elevated being. So of course I had one. Clean Code. I love Clean Code. Clean Code's a good book. Code Complete. Code Complete's another great book. But like who uses books anymore? Who uses books? Which is really sad because for several years I ran a publishing company. We published 400 and something books, and I just sort of realized like that's kind of dying. Like that's not sustainable going forward. Books are physical books. Like who wants those? That's why I came back to teaching. All right, so pub sub. I've got a subscriber. So the way this works is the publisher has some interesting information. It could have a whole bunch of information. The subscriber calls the subscribe function on the publisher. So these things in this lower box, these guys are functions on this publisher object. When we talk design patterns, we're usually talking objects of some sort. So here's a publisher object. It has a subscribe method on it. So he's got a plus next to it. The plus means that's a public method. So everyone can see the publisher's subscribe method. So when a subscriber is interested in some data, maybe a stream of data, it'll call that subscribe method. And what the publisher does is it takes the subscriber's information and basically builds a linked list out of it. So back on this side, oh, this is going to go well. Back on this side, let's make that tiny if I can. That's not terrible. Back on this side, I've got a whole bunch of, this is a list. I've got a linked list of subscribers. Bip, bip. And let's turn you around. Comme ça. Let's make it look like that. Perfect. That's a linked list. That's a linked list of my subscribers. It's built by the subscribe method. The subscriber, when the subscriber essentially sends itself to the publisher and says, hey, I'm interested in this topic. And by the way, every freaking semester on the midterm, there's a question on this on the midterm, every semester I get like 5 students who say, publish subscribe is like a magazine. When you're interested in a topic, they send you a magazine, and like, nah, it's not quite that. Not quite. They just see publish and subscribe and assume it's like a magazine kind of thing. All right, so the subscriber says, subscribe me, sends it basically a pointer to itself. The publisher builds a linked list out of all those guys. When a topic changes, when model data changes, so there's a state change on the publisher side, it goes through the list and calls the notify subs. Notify subs walks through the list. It calls the notify method on each of the subscribers. So I essentially have a copy of this. Whoa, they're all connected. I got a copy of the subscriber, or a reference to it at least, over here in this linked list on the publisher side. So it says, goes to the first one and says, oh, hey, you said you were interested. It calls the notify method. So that notify method just tells the subscriber that there's new data. It might also send the new data, but it could be just notification, and then you got to go and request the new data. Just depends on how you built the app. An example would be, like we use this all the time in financial services. So there are companies like IDC and Reuters and a couple of others that provide data coming off of the exchange floors, like the New York Stock Exchange, Chicago Board of Trade, and so on. Chicago Board of Trade. Every time a transaction occurs, a sell, a buy, like whatever the vehicle happens to be, anytime a trade occurs, that generates a data point, and it's information like what was the size of the trade, how big was the block, what was the ask price, what was the bid price, everything else essentially, what was CUSIP, the identifier for the security. All that data is encapsulated in an object, or something that looks like an object. It's a piece of data, JSON maybe. That is called a tick. So those ticks flow out of the exchange into pipes coming out of IDC and Reuters. They're data pipes. A company like State Street Bank would subscribe to that. They would pay Reuters for that data, and they would say, hey, we're interested in bonds and stock futures. That's the data we want to see. Well, this huge flow of data coming out of the exchange, some of it is bond information, some of it's stock futures, and just tons of other stuff, of course. But the Reuters code would go through and say, oh, I got a change in bonds. So I got a new bond tick. Who was interested in bond ticks? And would send them out the pipe to those subscribers. Zach said, it's like the magazine. If the magazine lined everyone who was interested in a single file, and this send somebody to walk through the line to tell everyone, yeah, I guess so. And you have to send a request back up the line to read the story, right? It's not a bad analogy. Don't use that analogy on your exam, because I told all the graders if they see magazines to mark it off. Anyway, that's pub sub. It's a really, really handy architecture when you've got you've got clients who are interested in different things. If everyone was interested in the same thing, that's just straight up MVC. You know, changing the model, all the clients get notified. Here, there's a change in the model, but only select clients get modified, just the ones who have subscribed. And of course, there's all sorts of stuff that goes around that, you know, unsubscribe, limits, you know, and caps on the data flow and so on. You know, there's more than just this little diagram, of course. But this, again, is a, you know, this is an architecture we see all over the place, especially in financial services, healthcare, the businesses I was in, where there's just a lot of data being generated, and you don't need to see all of it. Boy, we got nailed once at, it must have been Fidelity. We were working on a project, and we needed, we were testing, and we were testing ticks coming out of, I think it was IDC. And so we were testing out the wazoo, you know, data in, crunching all that data, spitting it back out. And then a couple of weeks later, we get a call from a VP. He's like, of course, everyone's a VP there, but I get a call from a VP. He's like, what's this bill from IDC for data? And we're like, what? And we looked at it. We had accidentally attached to the live feed instead of the test feed. The test feed was free. The live feed was like a penny a data point or something. And we had racked up thousands and thousands of dollars of data charges. Unfortunately, IDC was pretty cool about it. They just said, yeah, pay us and we'll let you keep working with us. So we paid the bill. But just be careful. There's, you know, there's almost always a test server and a production server. Just make sure you're testing against the test server. All right, so that's pub sub. Pub sub, pipelines of data. In fact, that's just what I said, right? I note that it's more efficient than polling. Let's talk about polling for a sec. So in a polling situation, I'm actually going to draw this one because I have a moment. Let's just draw polling really quickly. Shapes, yeah, whatever. Change it up a little bit, right? So here's some shapes. Copy, paste, 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 paste. Bip, 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 bip. So here's a bunch of clients. And in the middle, I've got the model. Here's my model data. And these are clients. So the idea here is that if I'm doing polling, text, so this is polling. If I'm polling, each of these clients in turn is going to ask the model if it has any new data. So I've got all these connections coming in to here. It's going to look like one of the data architectures we looked at. So every single one of these guys, 3, 4, one more. Should have made fewer bubbles. All right, like this, and that, and this, and one more. Sweet. So in a polling situation, every single client, and it could be a round robin sort of poll, so they do them in order. Every client asks the model if it has new data. Do you have new data? 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 Oh, there's data. Do you have new data? Do you have new data? Do you have new data? So in polling, we just continuously ask the model if anything has changed. As you might guess, like, that's incredibly inefficient. And it's kind of why we moved more toward pub sub kinds of models, because it's just, it takes a lot of bandwidth. I mean, holy crow, if this is going over a network, especially, like each one of those is a network request, it's going to take a lot of time. That said, like polling, depending on your application, polling might be the fastest thing to do. If you're writing code that's going to be embedded in a controller for an engine in a car, maybe you're working on Tesla stuff, and it's a new controller for the battery situation, or the battery assemblies. Polling can be a really efficient way to handle that because there's nothing else happening. Like, I need to know if there's new data or not. I don't want the overhead of building out a pub sub sort of architecture because there's a lot of layers there. The most efficient way to do it in that specific situation is polling. just have the devices that need the data just continuously poll in a loop. And then when there is new data, they can run off and do something with it and then come back and start asking again. So there are situations where polling is the most efficient way to do something. It typically isn't on a network-based application just because the overhead of the network calls, but on embedded systems, I've written polling code, tons of it. I used to work on, back in the day, I was writing code to build controllers for laboratory instruments, and that was all polling. Like there was just nothing else happening. It was just a closed loop controller. And so I didn't have to worry about performance so much. I built it to be performant, to the level that I needed. And polling was the best way to do it in that case. Actually, that's a really good point. Like, as you talk about architectures, like we talked about some in here, as you talk about it with your friends and colleagues, like you'll often hear, oh, should never use polling. Like that's really inefficient. Well, it exists because there is a use case for it. If it wasn't efficient in some situations, we just wouldn't do it at all. So don't have a closed mind when you think about this stuff. Like always, just think it all the way through and don't dismiss something just out of hand because somebody said it wasn't the right thing to do. Maybe it is the right thing to do in that situation, and they don't know. So there you go. So polling, that was pub sub. They're relatively similar. They just sort of turn it on their heads, right? Here, it's the publisher notifying subscribers that something has changed. Here's the clients asking the publisher if something has changed. So it's really just two different directions of kind of the same model. So pub sub, that is pub sub. It makes me hungry. It's like to go to a pub and have a sub. That'd be awesome. A beer. Oh man, what I wouldn't give. I cannot wait to get back out and sit at a bar somewhere. James pulling me back to earth. What's an example when polling would make more sense than pub sub? James, dude, I just like spent 10 minutes talking about it. Wake up. Just kidding. Seriously, it would be like an embedded controller where I need data from some subsystem, and I don't care about performance because there's nothing else happening. And in that case, it's probably more efficient just to have the clients poll. So what else are they going to do? That's all they have to do. And it's a closed kind of system, like a closed loop sort of thing. So it just depends. Just depends. And honestly, it's a really common interview question. Like, how would you lay this out? And like a really, really good thing to say right up front is, well, it sort of depends. Can I ask some questions about like, what are the performance implications? Like, what environment is this in? What's the target? That sort of thing. Like definitely ask questions. A, it gives you some time to think while they're answering the questions. And B, it just tells the interviewer that, oh, they're a little deeper than most candidates. Like they're actually thinking about this stuff. James asked, don't mean to be too much in the weeds, but wouldn't interrupts and stuff be the better way? Yeah, James, actually you have it. It's a trade-off. If I'm generating interrupts and handling interrupts, that's a really different system. That's an asynchronous kind of thing where now I've got to have code that's watching for interrupts. I have to handle those interrupts as they come up. I've got to notify clients, when there is an interrupt and decide like who needs that data and everything. Yeah, cool. Interrupts are a great way to go. And, like modern operating systems, that's how they work based on interrupts. But I can think of situations like in controllers that I've built where interrupts would just be too much. Maybe I've only got 4K of code to work with, for everything. I don't have room to build an interrupt handling system of some sort. And it might be that in that particular application, like synchronous operation is much more efficient than asynchronous operation. Yeah, cool. I didn't mean to rag on you, man. Like again, it just depends. It depends on what you're doing. And it's why we talk about all these sorts of shapes. Like you just have to think about all the shapes and what makes sense for what you're doing at the time. There is no one size fits all kind of thing here. Yeah, exactly. If it's shipping at the end of the week, it's like, it's going to pull, baby. And then what? Day 2, now we're going to work on the interrupt system. And I just bought myself another 6 months of consulting. Let's talk pipe and filter. This is batch essentially. Yeah, man. And by the way, James, like that's what I like this class to be. I just like the. It's hard because there's only a few people in the room. You know, it's like I just like to have conversations about this stuff and just talk about like, oh, what about this? What about that? Yuval says while loop with 4 lines of code for polling versus something a little more complex. Yeah, it's always going to be more complex with pub sub. But that, again, Yuval, like that's a trade-off, right? Yeah, come on in, man. Alvin, where are you? Are you on campus? Yeah, cool. It's fun. I mean, it's not the greatest room, and there's some folks. I mean, it's a small room for sure, but yeah, there's probably a dozen seats in here that are good seats. I don't mind. I don't mind. For a while, like last semester, I was all bent out of shape because I was lecturing in Sci with 500 something seats, and there were 2 students. Sometimes there was 1 student, and they sit way in the back. Like it was just brutal. Here, like I've got some folks in the room. It's a little more cozy. But yeah, you're welcome to come on over. I mean, don't worry about those silly, oh, sign up for a seat and all that. It's like there's plenty of seats. All right, let's talk pipe and batch, pipe and filter, which is batch architectures. This, this is really heavily used on the Unix side, and most businesses, I guess, gotta remember where I've been. So most industries that I've been in, financial services, healthcare, transportation, shipping, all of them, banking, like all of them have stuff that they need to process, and usually after hours. So let's say I'm an investment firm. Like my clients have portfolios of stocks and bonds and so on. Well, for sure, those prices are going to be fluctuating during the day. But at the end of trade, when the market closes at 4:30 or 4 o'clock, like I need to now calculate a value for those portfolios based on the close of whatever equities they were holding. That's something I'm going to do in batch. Batch processing is mainly, it's usually number crunching, reporting, like data manipulation of some sort that I just need to do in one chunk. Um, I might write a batch to do check processing. So I've got, at the end of the month, maybe I got to pay all my employees. I got 100 of them or something. I'm going to run that as a batch job. So all the data comes in to the batch job runs. And at the end of the chain, checks are being sent out. So it's typically something that's done, I was going to say offline, but sort of off time, at the end of the business day or a business period, like a quarter or a week or something like that. And it is non-interactive. So this is not something that people are like engaging in. You start the batch process, it runs and it's done, and that's it. You get whatever came out of it. These look like this. So here's one. Each of these pieces, validate, sort, and so on. These are stages in that batch. And the batch starts here at the top. So I receive some data feed. I go and validate the data, sort it all out. Here I'm computing dividend payments. So I'm going to do a compute dividends step, apply them to the accounts, and then that feeds another batch process that's going to go and do all the reporting for me. It sounds really archaic. Like, it sounds very archaic, right? Like we're used to using really fancy applications and mousing around and so on. But this is the bread and butter of most businesses. Every place I've ever been has had some sort of batch system where they're running batch jobs at night or the weekend, end of the quarter, and so on to crunch numbers. What's the, by the way, where's the bottleneck in this? Where's the bottleneck? Where's the performance pinch point? It's everywhere. The entire batch is a bottleneck, right? Each of these things is a separate step. So I've got to complete the validate step before I send it to the sort step. If that slows up, guess what? If this validate piece is late, sort's going to be late, that's going to be late, that's going to be late, and that's going to be late too, because each one feeds into the other. The example I often give is, like let's just take a quick look here. I'll make this big for you. Make my prompt a little smaller. So let's say that I want to, let's say I've got a text file. Let's see what's in, oh, I've got a lorem, great. So here's lorem.txt, it's just a bunch of words. But let's say that I need to know how many characters are there and how many unique ones. So I might do this. I might just set up a pipeline here. And in Unix machines, you literally use the pipe character to connect these things together. So the way I would do this is, here's what cat lorem.txt looks like. So that just prints it out. That's the whole text. So I can cat it out. So let's cat lorem out. And then I'm going to pipe it into, that's the output of cat. Cat just prints stuff out, but I'm going to take that output and pipe it into the input of something else. I'm going to pipe it into the input of, I don't know, let's do unique maybe. So I take the output of the cat, I pipe it into unique. Unique is going to give me all the unique words. And then maybe I'll do a word count. Why does that keep doing that to me? Hang on, let me just do this. There we go. So I'll pipe it into unique. And maybe from there, I'm going to just pipe it right into word count. And that'll give me characters, lines, and words, and so on. Or maybe I'll sort it too. Once it's in unique format, I can sort it. Like that. And what I get is this. So there's 17 lines, 603 words, 4,011 unique characters across all of that. But these are separate. Like cat is a program, unique is a program, sort is a program, WC is a restroom. I'm sorry, it's a program. Like that is, those are individual programs, but they accept input from the output of something else through this pipe character. That's why we call it pipe and filter. I'm piping into unique. Unique filters that data somehow. I take that and pipe it into sort, which filters it again for me. So Unix systems are just built like this. The output of one thing can always be sent into the input of something else using a pipe character. And that would be sort of an example of pipe and filter specifically. And then the batch piece comes with, I'm going to run this as a group. This entire thing runs as a batch job with some input, and it's got some output. Now, usually there's going to be some tool like IBM Maestro, maybe text, like a tool that we see a lot of places is IBM's Maestro. Maestro is a batch manager, so you can tell it, hey, here's the batch, here are the components of the batch, here's what the input looks like, the output, here's when it should run, and Maestro will handle scheduling the batches, making sure they run in the correct order. If there's an error, it can restart or notify somebody. Like a lot of control over the batch process. Trying to think of other companies too. Everyone I know uses IBM Maestro, so I can't even think of anyone else's. I'm sure Oracle has one. Who else would have one? I don't know. Tons of them, I'm sure. But Maestro is the one that everyone uses. It's expensive, but everyone uses it because it works really, really well. To illustrate the bottleneck problem. So one of my clients, whose name starts with an F and ends in Fidelity, it was several years ago. So they called my firm in for a called us in, we were already there, but it was a new job for us. They called us in for a firefight. The problem was that this was on the defined benefit side, the retirement side. So pensions, basically. Yeah, it was the pension side on defined benefits. So they had recently landed new business. It was PepsiCo. Pepsi was a huge, huge client for them. It was a big, big deal. I remember when that deal closed, there was champagne everywhere and a lot of happy people and a lot of new Porsche Boxsters sitting out in the parking lot. It was a big deal for the company, big, big piece of business for them. They actually called us in, and I looked at that specifically. They wanted to know if their existing process for handling checks would work with that size of a client. And it was this kind of thing. It was, they're going to receive a tape essentially from PepsiCo or their other clients as well. And then they crunched those numbers down, and the output was a monthly pension check. So it was here's who's owed money, here's their accounts, here's the rates, here's the withholding. All those were batch steps, and then finally at the end it would spit out checks. Well, the problem was actually it looked fine. Like I took a look at it, it's like, yeah, I guess this will work at a high level. Like, you know, seeing any huge performance issues. I heard they also brought in, so at the same sort of time frame that the champagne was flowing, they came in with hand trucks and took out all of the Coke machines out of the building and installed Pepsi machines. I guess that was part of the deal. It's kind of weird. Riders, huh? It's like brown M&Ms. Yeah, so it's like, yeah, I'm pretty sure, you know, you can handle Pepsi, fine. Well, then 4 or 5 months later, they landed another big client. It was Ford Motor Company, and all those union workers and just massive, massive pensions. I mean, just we're talking a huge amount of data. And what started happening was the checks started getting out late. The batch process couldn't handle both clients of that size. And so everyone was running late. And man, you do not screw with people's money. If you're a pensioner and your check arrives late, you are on the phone to as high a level as you can possibly get, or you have nothing else to do, right? So you're going to drive down there and demand to know where your check is. These people were not happy. And so we took another look. It's like, all right, so we took kind of a high level look earlier. Like, so let's really dig down into this and see, like, what are you doing? Where's the pinch point? And what we found out was, oh God, I'll never forget this. What we discovered was they were getting tape, let's say from Ford. So they got a tape at the end of the month from Ford, and it had all of the pensions on it. Here's, you know, all the stuff we need. They would start the batch process. The start of the batch process involved taking that tape, printing the data on paper, and then they would take the paper copy and type all the data back into Excel. And then they would move it through the rest of the batch process, which ended up in checks. What was the very first question we asked them when we saw that in the meeting? What do you think our first question was? Let's see if you guys come up with it. Was that why are you doing this? And the answer was, we have formulas in Excel that validate the data. So that was their validation step. We don't trust the data on the tape. We want to validate it in Excel, and then we can move it through the rest of the process. They were hand typing it, James, back into Excel from paper, no less. Yeah, no kidding. I mean, I know. Like my inclination was just to walk out very slowly, like back out and not try to do, don't make them nervous. But what we told them was, look, like there are a lot of ways that we can take your Excel formulas and write that into code so that you can just read the tape right into a process that'll do the validation with your Excel formulas. We can test it, you know, like crazy to make sure that you're comfortable with it. It's going to take us like 3 months to do that. And they're like, okay, that's fine. So we got a short job to come in and fix that piece of the process, but it was getting later and later and later. They actually, most large financial services firms had trouble in the kind of early 90s when we had a horrible crash in 85 to 88 or so. And then when money started flowing back in the 90s, like they couldn't keep up. Same idea. Batch processes were slowing down like crazy. There's a lot of batch work back in the late 90s. That's why we don't have flying cars, right? Uh, anyway, so we did it. And, you know, it all worked at that point. Guess what they did in the interim? Anyone want to know what the solution was short term? Because they had 3 months worth of pension checks to get out and they wanted to get them out of time. What was the solution? What would you guys do? Hey, James has it. They hired interns. So they brought in a whole batch of interns to do more typing. That's how they managed it. Yeah, that was the solution. Give up. Yeah. Yeah. Oh yeah. Give up. Tell the pensioners they're not getting their checks and see what happens. You have to change your name and move. Yeah, so they just hired more interns for a couple of months to do all that typing and to get caught up essentially. And then our stuff kicked in later on after we tested it and they were all fine. Silly stuff, man. But you do what you got to do, right? Sometimes, the stopgap is what you got to do. The danger though is like when you have stopgaps like that, like us, bring more typists in every month at the end of the month to do typing. The problem is that if somebody leaves and let's say it went on for 5 months or 6 months, at some point it's going to become like the new normal. That's probably what happened with the Excel spreadsheets. Like there was probably some issue years prior to that, and there was a bad piece of data, and somebody on the team said, "Oh, I know Excel really well. I'll just write a little formula to check that on each one." And so they were typing that in, and then eventually they forgot why they were doing it. And then you forget why you have all these typists in. It just becomes part of the procedure. It's the old, that's the way we've always done it argument. And sometimes you need somebody from the outside to come in and shake it up and say, well, no one else is doing it that way. Like, why are you doing it that way? And just ask why and why and why over and over until you get to the root of the situation. Anyway, that's batch. So batch is non-interactive. We're not interacting with this at all. Usually run at night or off hours, and it's doing reporting, number crunching, heavy lifting, essentially. We see a lot of batch jobs running on mainframes because they're so good at crunching. So batch, run a lot. And that's the bad, those bottlenecks are everywhere in batch. All right, I can't stall anymore. Bottom line. The bottom line is just as I mentioned earlier, when we're talking about polling and pub sub and so on, like every problem is unique. I know last week I said every problem is exactly the same, but really like the architectures need to fit the problem, and companies that try to have a single architecture for everything always suffer in the end. Everything really does need its own specific architecture, and they're going to fall into large classes, families of architectures for sure. But most of the time we're looking at relatively unique solutions, within that family of architectures. Um, it's just always going to be different. And my advice to you guys is to start with the abstractions. If you start with abstract pieces, like, oh, data validation, that's pretty abstract. How am I going to do it? That's the concrete piece. But I can just talk about validation as, something really high level. That's the abstract piece. Or, that call and return architecture we looked at, the abstraction there is the middleware. I'm going to make a generic call, get a generic response back. I don't have to worry about the details so much. I can draw large block diagrams with the abstractions in them, get the correct shape. That's the design. And now I can start to fill in details. I'm agnostic at that point to technology. Like when I'm drawing abstract diagrams, I'm not thinking about technologies at all. Like, what's this going to run on? What language and so on? It's like, I don't care. It doesn't matter really, because this is what the application needs to look like, its shape. And then we'll just fill in the details as we go. That's implementation details. Usually implementation's easy. I can ship that off to some third party and have them do it even. Also, and that's the design in a way you can easily move between architectures. So that just means thinking in the abstract and delaying any implementation details until as late as you possibly can. A lot of times, as I said earlier last week, like, sometimes you're just stuck. You're an Oracle shop. I got it's going to be Oracle 12i running against a relational database, in a pub subsystem. Like that's what we use, and that's what we know, and that's what we're going to do. So sometimes you're stuck. But all that to say, that was a lot of slides. Architecture rocks. Like I love thinking architectures and the best way to approach problems. Like that's the really fun part of this kind of work, I think. The coding's fun too. I actually love coding. I'm not a really good coder, so I'm not great at producing production code, but I can build and design like crazy. That was my forte. All right, guys. So that's looks like that. Oh, they're all blank. Haha. All right. So that's it for software architectures. Obama. That is it for software architectures. I'll post a note on Piazza for you guys talking about the midterm and what the plans are for that, so everyone sees it. But look for that at the end of the week. And what were we talking about Thursday? I don't remember. Oh, UML, I think. I know, I just added up. I can't remember. Thursday is, yeah, system modeling. All right, guys, that is it. Go be free. Enjoy the beautiful weather. It's probably 60 out there at this point.
Thank you,
See you
Professor. You
all.
have a nice day too. Peace.
Come on. Bye, Alvin. Stop sharing. And for all